Hey everybody. So today, well, first I feel like we need to talk about number of the day because I have completely lost track of what the number of the day is. And if anyone has an idea, I'd be glad to hear it. I know we left off at I don't even know, 50 something, 40 something. We're probably in the low 40s at this point. If anyone knows what the number of the day would be, I'd be happy to hear about it. But let me know if you know what the number of the day is. In the meantime, we need to move on to the next section, and that is radians. What is a radian? When we started doing trigonometry, I had you switch your calculator from radian mode to degree mode, but I never really talked about what radians are. So that's what we're doing today. You could probably switch your calculators back into radian mode if you haven't already, but let's see what a radian is. A radian is, well, it's defined like this. If I'm on the unit circle, you know it, you love it. The unit circle looks like this. And a radian is defined as this distance, not the straight line distance, but this curved distance along the unit circle. If I have an angle of, well, 1.12, that means this distance is 1.12. So if this distance is 1.12 on the unit circle, then that measure, this radian measure, is 1.12. And I know that's a different way to think about it. That's unusual. That's a strange way to think about it, but that is what a radian is defined as. On the unit circle, this distance, this curved distance, this arc length is the radian measure of that angle. So if we have a 360-degree angle, if we're going all the way around the circle one time, what would be that radian measure? Well, let's just think. If I've got a unit circle, 1 unit in distance, this circumference, the distance around the circle, pi times diameter, diameter is 2, pi is pi, 2 times pi is 2 pi. That means one full rotation, 360 degrees, is 2 pi radians. And that's where all of this stuff comes from. Everything that we do over the next few weeks, everything you see from radians over the next few years comes from this fact that the distance around the unit circle is 2 pi radians, which means if I've got half a rotation, 180 degrees, that's half of 2 pi, that's pi. And this one's going to be big. 180 degrees is pi radians. We'll come back and take a look at that in a minute. Half of that, 90 degrees. Half of 180 is half of pi, pi over 2. Pi over 2 is the same thing as a 90-degree angle. Half of that, half of 90 is 45 degrees. Half of pi over 2 is pi over 4. Pi over 4 is 45 degrees. Remember that. Keep that in mind. We're going to see that again continuously over the next few weeks. Now, after that, half of 45 is 22.5. That's not a big deal, but 1/3 of 180 is 60 degrees. 1/3 of 180 is 60 degrees. 1/3 of pi is pi over 3. That's another big one. And then finally, half of that, half of 60 degrees is 30 degrees. Half of pi over 3 is pi over 6. These are the big three. 45 degrees is pi over 4. 60 degrees is pi over 3. 30 degrees is pi over 6. Those are the ones that you definitely want to commit to memory. But honestly, the one that's big is 180 degrees is pi, because that gives us a conversion. 180 degrees is pi. Pi is 180 degrees. This is our conversion. 180 degrees is the same as pi. Pi is the same as 180 degrees. Just like 3 feet is the same as 1 yard. So if you're converting from yards to feet, feet to yards, this is the conversion that you think about. 1 mile is 5,280 feet. 5,280 feet is a mile. That's the conversion. And all of these conversions that we've seen before, these are the same thing. If I want to convert moles to atoms, 6.022 times 10 to the 23rd. If you've seen this in chemistry, this is the conversion factor from one to the other. So This is the conversion that we keep in mind as we do all the rest of the conversions that we're going to be doing. So if I say convert 72 degrees to radians, excuse my sloppy handwriting here, but if I want to do 72 degrees and multiply that by pi over 180, this is going to give me the conversion from degrees to radians. So 72 pi over 180, oh, let's see, 72, 36 goes into 72 two times. 32 goes into 180 five times. And I've got 2 pi over 5. So there we go. 72 degrees is the same as 2 pi over 5 radians. That's the conversion. In the other direction, if I've got 5 pi over 7, I say convert this from radians to degrees. 5 pi over 7, well, let's see here. 5 pi over 7. My conversion, well, 180 degrees is the same thing as pi. So multiply by 180 over pi. Pi cancels out. I've got 5 times 180 over 7. Well, 5 times 180 is 900. And there we go. 900 over 7 degrees, whatever that is. And if we have a calculator, we can plug that in. Otherwise, 180 degrees over 7, it is what it is. 900 over 7 degrees, that doesn't simplify any more than it is. So that's what we're stuck with. What I'd like to focus on is something like this, 7 pi over 4. And I realize I've got that written as 7 pi over 4, but I'd like you to think of it as 7 times pi over 4. Because pi over 4, that's 45 degrees. Pi was 180 degrees, 1/4 of that is 45 degrees. And so when I see 7 pi over 4, honestly, I'm thinking about the unit circle. I'm thinking, okay, on the unit circle, I'm rotating by, let's see, 45 degrees. Looks like that once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, and there we go. I've got this angle over here that's either 45 degrees more than 270 degrees or 45 degrees less than 360 degrees. And I'm thinking that must be the same thing as, let's see, 45 degrees less than 360, that's 315 degrees. And really, I think in the long term, if that's how you think of these problems, that's going to pay off. Yes, you could take the 7 pi over 4, you could multiply by 180 over pi, but if you think of it as 7 times pi over 4, 7 times pi over 4, 7 times 45 degrees, 1, 2, 3, 4, 5, 6, 7 times pi over 4, that brings you to this 315-degree angle. That's the angle that I want you guys to think about, 315 degrees. Similarly, going in the opposite direction, 135 degrees. Ooh, 135 degrees. I'm going to the unit circle. I'm thinking about that. 135 degrees. That's over here. 135 degrees. That's, well, it's 45 degrees 1, 2, 3 times. 45, then 90, then 135. And so it's 45 3 times. Well, that's 3 times pi over 4. And 3 pi over 4, that's our conversion. If you take 135 times pi over 180, that fraction will simplify to 3 pi over 4. That's the conversion that we want. So when I say what is sine of 3 pi over 4, well, we just saw where 3 pi over 4 comes from. 3 pi over 4 comes from pi over 4, that's 45 degrees. There's 2 45 degrees. There's 3 45 degrees. That puts us right here on the unit circle. Excuse my sloppiness with the computer. But there we go. That's the angle we're looking at. We're looking at the 45-degree angle. We're looking at a 45, 45, 90 triangle on the unit circle. If I say sine of 3 pi over 4, that's the vertical component of that. Vertical component, square root of 2 over 2. The vertical component of the 45, 45, 90 triangle in the unit circle, we're moving up. And so square root of 2 over 2. Tangent of 5 pi over 3. Let's see, where's 5 pi over 3? I know pi over 3 is 60 degrees. So I've got 60 degrees, 120 degrees. That's 2 pi over 3. Here's 3 pi over 3. 1 pi is 180 degrees. 4 pi over 3 is down here at that's 240 degrees. And 5 pi over 3, that's 300 degrees. So what's tangent of 300 degrees? Either you know it because you memorized it, or you're looking at it as sine over cosine. Sine is square root of 3 over 2. Cosine is 1/2. And so tangent is square root of 3 over 2 divided by 1/2. And square root of 3 is the answer. That's what we're doing today. The conversion from radians to degrees to radians. If you have any questions, certainly check in with me. Let me know. Otherwise, I will see you again virtually on Friday. Bye-bye.